What we're supposed to do in here is simplify this expression, and we're supposed to use the ladder method or the factor tree. You guys can choose, it doesn't matter to me. What I'm going to do is start by breaking 108 down in by factors of 2. If I divide 108 by 2, what do I get? 54. We can divide that by 2 again, and I get 27. Can I divide that by 2 anymore? What goes in though? 3 goes in 9 times. 3 goes in again 3 times, and I'm left with a factor of 3 at the end. Now, what's the rule for radical expressions? How many do I have to have in order to take 1 out?
2.
I have to have 2. So if I have 2 2's here, I'm going to take 1 factor out. I have another pair of something. I have 2 3's. So I get to take 1 factor of 3 out. What's left over at the end that has to stay underneath? A factor of 3. So my answer for number 1 should be 6 square root 3. Okay, same thing on 27. We actually just did the ladder method on 27, but we'll do it again here. For 27, we'll say 3 goes in 9 times. 3 goes in again 3 times, and we're left with the factor of 3. Again, in order to take out one number, I have to have a pair. So I have a pair of 3's. I get to take out 1 factor of 3. What's still left underneath? A factor of 3. What do I know about this answer, though? That it needs to be negative. Number 3 is a little bit different because we have a number on top and on bottom. So the first thing I'm going to do on number 3 is split it up so that it looks like 2 separate things that I'm taking the square root of. So I have the square root of 11 over the square root of 16. When I go to simplify that, can I break 11 down? No, it's prime. So the square root of 11 is going to stay underneath that radical symbol. What's the square root of 16? 4. So my answer is going to be the square root of 11 over 4. Can I simplify the square root of 18? Yeah, I can. So I'm going to ladder out 18 first. What goes into 18? 2. How many times? 9. What goes into 9? 3. 3 times. What can I take out of 18? The pair of 3's I get to take out. What stays underneath? The 2 stays underneath. And we're going to leave it negative on top. What's the square root of 49 on the bottom? 7. So your answer for number 4, you should get negative 3 square root 2 over 7. Okay, number 5, we have 6 plus the square root of 44 over 2. Again, we're always going to simplify any radical expressions right away. So 44, if I break it down, what goes in? 2. How many times? 22. What goes in? 2 again. 11 times, and 11 is prime. We'll put that. So 44 simplifies to 2 square root 11. So that's what I'm going to rewrite this problem as. 6 plus 2 square root 11 over 2. Now, we had some like this in the homework. What can I do with the 6, the 2, and the 2? Can I not simplify those numbers? Don't they all share a factor of 2?
Yeah.
So what I'm going to do is cross out those 2's and then take 6 divided by 2, which gives me what?
3.
So we have 3 plus the square root of 11 over 1. So I'm just going to leave it as 3 plus square root of 11. I'm going to start by simplifying the square root of 32. It's pretty similar to the last one. 32, if I break it down, what goes in? 2, how many times? 16. 2 goes in again 8 times. 2 goes in again 4 times. 2 goes in again 2 times. And finally we get to 1. How many pairs of numbers do we have? We have 1 pair of 2's, we have 2 pair of 2's, and 1 left over. So what 32 is going to simplify to is 2 times 2 square root 2. 2 times 2 gives us what? 4 square root 2. So now here I'm going to rewrite this whole problem. Negative 4 plus 4 square root 2 over, we'll just write the bottom number as negative 10. What factor can I take out of all of those numbers? 4, 4, and 10. A factor of 2. So if I cross all these out and take a factor of 2 out, again, not taking it out of the radical symbol, I'll have to mirror this up for you guys. So it's going to be negative 2 plus 2 square root 2 over negative 5. This was a section where you guys were supposed to go back and copy all those rules, things like product of powers, quotient of powers, and all those kinds of things. So when I'm multiplying and I have the same base, what do I get to do with my exponents? Add them. So number 7 should say x to the 9th. Very good. Number 8, what do I get to do and what bases are the same? The n's are the same. So 6 is going to stay in the problem, and I have n to the 4th over n to the 1st. What do I do with those exponents? Subtract. What's 4 minus 1? So my answer should be 6n to the 3rd. Very good. What we do on number 9 is we take that 2 on the outside, this 2 out here, and we take it to every single term. So it's going to be 4 to the 2nd power, x to the what? 6th. Very good. And y to the 4th. And you guys could take that one step further and evaluate 4 squared and put 16 x to the 6th, y to the 4th. Other than that, that's all you can do. So 16 x to the 6th, y to the 4th, and that's because we took that 2 to every power. When there's parentheses, we just take it to both terms. So up on top, we have that 3. We're going to take it to both terms. So on the inside, when you take that 3 through, it's going to be x to the 3rd over 3 to the 3rd. And you can evaluate 3 to the 3rd and get 27. So your final answer on that one should be x to the 3rd over 27. Product of powers, we add our exponents. So on number 11, where it says x times x to the negative 3rd, what's really up there with this x? A 1. So what's 1 plus negative 3? X to the negative 2. It says in the directions to simplify using only positive exponents. How do I do that? How do I make that exponent positive? I move that 2 to the bottom, 1 over x to the positive 2 power. Again, negative exponents do not mean change the sign of the base. It means the reciprocal of the value where the base is. So your answer for number 11 should be 1 over x squared. Number 12, what do we do with the 3 and the 7? We subtract. 3 minus 7 gives me what? Y to the negative 4. How do I make it positive? 1 over y to the 4th. Again, it's just those exponent rules. So again, in here, they don't get too much more complicated, but as we get into algebra, they combine all of those rules, so you need to be really familiar with them.